Now here in this video, we want to evaluate the limit of the function x over the absolute of x as x tends to 0. It can either be from the right or from the left. So to evaluate this limit of this function, I'm going to say let's evaluate the one-sided limit, that is as it tends to 0 from the left and from the right. Alright? Now, given this function, x over the absolute of x, from definition when we talk about the absolute of the function, the absolute value function, okay, we'll get on with it. Now here, I'm going to start by evaluating the limit as x tends to 0 from the left, okay, of the function x over absolute of x. Now this, from the absolute notation here in the denominator, we can rewrite this in the form of a piecewise function as the limit as x tends to 0 from the left of, now the function will be x over x, the denominator will be x, if x is greater than or equal to 0. In fact, x should not be 0 when we're dealing with x over x. If x is 0, you're going to have an indeterminate form. That will be very bad. But this is just from the definition, right? And again, we're going to have x divided by negative x in the denominator. That is, if x is less than 0. This is just a definition from the absolute notation we have in the denominator. Look at where this thing is going to. So here, we're going to have that if x is greater than or equal to 0, we have this function x over x. But if x is less than 0, we're going to have x over negative x. Now, we are taking the limit of x as x approaches 0 from the left. What are we saying? This is just 0, and this is a number line, it's a point 0. Now, on the left, on the left of 0, we're having negative numbers. So if x is approaching 0 from the left, that means x should be a negative value. Let's say a value sufficiently close to x. So because x is negative, x is less than 0. And because of that, we're going to make use of this function. So you just go ahead and say the limit of x divided by negative of x as x tends to 0. First of all, we're going to simplify the function, and that's just going to give us the limit of x divided by x is just negative 1. The limit of negative 1. In fact, negative 1 is a constant value. As x tends to 0, the limit of a constant as x tends to any value is just the constant, negative 1, like that. So this is the limit as x tends to 0 from the left. This is from the left now. Okay, how about the right hand limit? Now, the right hand limit will be when x tends to 0 from the right. Okay, so we're still going to make use of this. You see, we just have the limit as of x over the absolute of x as x tends to 0. X tends to 0 from the right. Well, using this notation right here, if x tends to 0 from the right, that simply means that x is greater than 0, right? And if x is greater than 0, we're going to make use of this function, x over x. So we just rewrite it as x tends to 0 from the right as x over x. Like this, we just have it to be the limit of 1 as x tends to 0 from the right. Okay, so this is just the limit of 1. Remember, just the constant we had here is just going to give us 1. And here, you see that the limit as x tends to 0 from the left is not the same thing as the limit as x tends to 0 from the right. Therefore, we have that the one-sided limit, the left-hand limit and the right-hand limit are not the same. That simply means that the limit of this function as x tends to 0 does not exist. Okay, so we say that the limit does not what? It's not the same thing as existence. The limit does not exist. So that's what you get by evaluating the limit of x over the absolute value of x.